Well, what you see in this room is basically what you've got in every room throughout this building. It's called a variable air volume system. And the only difference between this and a room that's got a lay-in ceiling is you'll have actually flex duct where this comes off on the side where you've got diffusers just coming off to the diffusers that are in the ceiling. But basically this is the same setup you've got everywhere. In a variable air volume system, what's coming into the inlet side of this is called a VA big box. What's coming into the inlet side of it is 55-degree air. Of course, the room's not 55 degrees, so what we're doing here at this box is we're doing two things. First of all, if the temperature drops below set point, there's a damper in there that's closing off. And once it gets to a minimum position, at that point, then you've got this coil, which is called a reheat coil. And once it goes to minimum position and the temperature is still dropping, then you'll start doing what's called reheat, and that's what the hot water system coil coming into. 55-degree air. Does anybody know what we're doing? Why the air is so cold? Why are we just not running at 72 degrees? Why we're running at 55? We're taking moisture out of the air before it gets here. So at the air handlers that we'll go see in the attic, that's what we're doing there. Removing the moisture, and then we'll reheat it here. We do two things. Like this time of year, we're running 55-degree air because we're starting to get into a more humid season, so we want to remove more moisture. But during the winter, we'll run that temperature up to between 63 and 65, and because of less humidity, we're just reheating for no reason at that point. So we're trying to minimize how much we have to reheat the air. Basically what you've got a control valve that controls the heat. See the actuator on the control valve there for the heating system. And then this is the actuator here on the side that controls the damper. It's back here in the back side of the box.
Where's the fan for it?
No, the fan is at the air handler itself. Yeah, it's just the air coming off the air handler. And there are systems that are fan powered boxes. We prefer not to use them, but a fan powered box will have a place you can take in air from the room, and the principle there is your return air versus it going back all the way to the air handler. Is you just take a small amount of your return air and put it back in the box and use a fan to pull it back out into space.
Where's the return area in this room, Don?
The return in this room. This whole duct back here along the back wall, I believe is the return. Yeah. And so the back side here is returning into the back side of this. This is the return duct. And anywhere you see the smaller ones in a room, those are usually the return for that room. But it is returning on the back side of that. That does happen.
Yeah, you want to tell them where this hot water comes from, the reheat?
The hot water originates, I don't know if any of you guys have seen the Central Energy Plant. It's down back behind the parking garage. There, you took it through there, right? Yeah, we're making 300-degree hot water, and we distribute it underground to this building. In the main mechanical room, it comes to a heat exchanger. At that point, we've got a building side of that heat exchanger. That's what this water here is. It's the building side of that heat exchanger.
It's a closed system.
It's a closed system.
This water temperature.
We vary it between 120 and 180. We have what we call outside air reset on that. So if it's 60 degrees outside, we're at 120 And if we go to 20 degrees outside, we're at 180. So we vary that temperature, try to save energy there also.
So in the winter time, all the hot air in this room comes from the heat pump.
Right. Yeah, if it needs heat, it's coming from that box right there.
And you said that there are boxes that have fans you guys don't like to use, but that is because it would be harder to access or something wrong.
Well, it's just another
Another part.
part. Yeah. Try to minimize the number, it's a motor, it's an actual
So you guys can do
fan.
complete maintenance on this without the classrooms ever being bothered. I mean, if there was a class, you guys could do whatever you need to upstairs.
Yes, for the air handlers. Now these control valves that you see here, for the damper and for the reheat, it goes into a calibration mode. Every morning, I believe at either 4 or 5 a.m., and it does a self-calibration. It goes all the way to 0, and then all the way to 100, and then back to the position that it needs to be.
So if you hear it 4 in the morning and you hear something in the ceiling, don't think it's a ghost. We'll be out of here. You need to be in here.
Okay, no, I'm gonna finish it up. I'm gonna pass it in about an hour or so.
We'll be out of here in 5 minutes.
Okay.
Oh, we get to say these, fails, what they've been doing.
Oh, yeah. Yeah, we've had several. Matter of fact, we had a professor down there, I'm not sure which professor it was. We just had a leak, was on the reheat valve itself, and was leaking down on his seat. Actuators, we replaced several actuators, several control valves. Not the valves themselves, just it's usually the actuator.
So when you have to replace one of those, do you just close the water off to each individual room or the room in question?
Right, yeah, so you got isolation valves right here, and you just shut it off there.
This room has a thermostat,
Right.
But we can.
but it's limited.
It's limited.
It's limited.
You can use it, it's just, we limit the thermostats between 68 and 74. So we've got a little bit of range, but there's people that want 60 and there's people that want 85.
We just assume that it's like
So once you dial in on that, thermostat, goes to a computer, and it doesn't let it go above.
And I say that, you're right to a point, a classroom, you have no control over the classroom. Offices, Henry does that, he's got that control of 68 to 74 in his office. But a classroom, we limit those really, it's between 70 and 74. We shorten it up a little bit.
As it does,
between 70 and 70.
each classroom has its own thermostat. The offices do not have our own thermostat. Dr. Chris Thomas's office has a thermostat for 5 offices. So if you want your control, I'm going to more, whatever's going
That comes down from the system office, the engineer with the UT system office, his standard is 1 thermostat per 3 offices. Yours may be a little bit over that, but typically it's 3. But it could be 5, just depending on how the system's set up.
the reason to be, just don't that one.
Yeah, I mean, you could put a VAV box in each individual room, but to cut down, basically what you'll have is a VAV box. And unlike this being a classroom, typically, if this was 3 offices, you would have this VAV box serving this office, and that office on either side. But one person in the middle, whoever's got the thermostat's got control. Something.
What is this type of present
I believe that is for that, I don't know what it is, but it's probably one for protection. It's supposed to be there. I don't know if they decided not to do this, haven't got to it yet.
When we built this building, we moved in here, the dean came around and said, who wants a projector in the classroom? Everybody said, I do, and there were too many items. So this one would be back up. We'll go upstairs.